Hey everyone and welcome. Today, we're going to talk about something really cool. A bridge being built between the way we talk and the way computers get things done. We're diving deep into how AI is learning to take our simple, plain English instructions and turn them directly into complex software actions. So let's get into it. Just think about that for a second. What if, instead of clicking through a million menus or writing complex code, you could just talk to your computer? Imagine saying, hey, go through my new emails, find all the invoices, and save them to the accounting folder, and poof, a little digital robot just goes and builds that whole workflow for you. Sounds kind of like science fiction, right? Well, it's a lot closer to reality than you might think.
Now, to really get why this is such a game changer, we first need to look at a major roadblock in the world of software automation as it exists today.
And this right here is the heart of the problem. There's this super powerful technology called Robotic Process Automation, or RPA. It's awesome for handling boring, repetitive office work. But actually building these automations, it's a grind. A developer has to manually dig through hundreds of different commands and painstakingly piece them together one by one. It's slow, it's tedious, and you know what? If you make one tiny mistake, the whole thing can just break.
So how do we get around this giant hurdle? Well, the answer is pretty incredible. We teach the robots to read our instructions directly. And that's where a really exciting field of AI comes into play.
First, let's just make sure we're all on the same page with what RPA is. The best way to think about it is like a digital workforce. These aren't walking, talking robots. They're software bots that live in your computer and can do things like open emails, copy and paste data, or fill out forms. All the stuff a human can do, just way faster and, without ever getting bored or needing a coffee break.
And this is the magic ingredient. It's called natural language processing, or NLP. This is the exact same kind of AI that powers assistants like Siri and Alexa. For our purposes, it's basically a universal translator that can understand your plain English request and convert it into the very specific technical commands that the RPA bot needs to do its job. It's the missing link.
Okay, so how in the world do you actually teach an AI to be this translator? Well, researchers have basically created a specialized training program, you can think of it like an AI classroom, to get these models fluent in the language of automation. Now, you can't just feed an AI one single example and expect it to learn anything. To make it really smart, the researchers had to get creative. They took an original command description, like the one you see here, and then they came up with 5 different ways a person might say that exact same thing. This variety is so important because it teaches the AI to understand the meaning behind the words, not just to memorize a specific phrase. The whole training process boiled down to this 4-step game plan. First, they gathered all the official command descriptions from a popular automation tool called UiPath. Then, they did what we just talked about. They created all those different linguistic variations to beef up the dataset. After that, they cleaned up all the data to get it ready. And finally, they use that data to fine-tune the AI models specifically for this translation job. And here are our star pupils. The researchers didn't build these AIs from the ground up. They started with incredibly powerful pre-trained language models. You might have heard of the big one, BERT. They also tested 3 of its cousins, DistilBERT, TinyBERT, and ALBERT. And each one has its own little quirks when it comes to size, speed, and overall power. All right, so after all that training, after all that work in the AI classroom, how did our models actually do? This brings us to the moment of truth, the AI model showdown.
So we've got our 4 contenders. The big question is, which one can translate what a human says into the right software command? And it's not just about being the most accurate. It also has to be efficient enough to be useful in the real world. So let's see what the numbers say.
Okay, looking at the raw data here, you can see a really interesting trade-off right away. BERT, that first one, is the clear winner on accuracy, over 94%. That is outstanding. But then, look over at the runtime column. It's also the slowest by a long shot, taking more than 13 minutes. And way down at the bottom, you have TinyBERT, which is pretty fast, but wow, that accuracy score is just not going to cut it.
In this chart, this really just spells it all out, doesn't it? On the left, you've got BERT with that sky-high accuracy. But then look at DistilBERT on the right. Its accuracy is almost 90%, so still fantastic, but it's a whole lot faster to run. And that balance, that sweet spot between being super accurate and super efficient is absolutely everything when you're talking about building a real tool that people will actually use.
So what's the big takeaway here? What does all this mean for the future of how we work? Well, it means we are right on the edge of a new era of smarter automation that's going to let us get things done way, way faster.
So at the end of the day, the study's big recommendation comes down to one word: balance. Yep, BERT is technically the most accurate model, but the researchers concluded that DistilBERT is the real winner, the best one to actually put into practice. And why? Because it hits that perfect sweet spot. It's highly accurate and highly efficient, which makes it the most practical choice for the real world.
And this isn't just some abstract academic experiment. The benefits for actual businesses are huge. You're talking about less manual work for developers, which means new automations get built way faster, which in turn lowers costs. But maybe the most exciting part is that it makes this powerful technology available to more people. It's not just for expert coders anymore.
And that brings us to a really fascinating final thought. As these AIs get better and better at understanding exactly what we want, that barrier to creating powerful software just gets lower and lower. It really makes you wonder, in this new world that's coming, who are the automators of the future going to be? Will it still be the specialized developers, or could it be everyone?